morning, everybody. I am Dr. S.S. Naidu, Assistant Professor in Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to discuss very important topic in probability and statistics, and we are doing very interesting problems on discrete and continuous random variables. See, already we have learned so much about discrete random variables and as well as in continuous random variable. Discrete random variable, specifically it gives a numerical value, a specific value. Like that, continuous random variable, it gives value for that random variable in a particular range, in a particular interval. So it is continuous. That's why it comes under continuous random variable. So continuous random variable, its value lies in some interval, some range. Whereas the value of discrete random variable, its value lies, its value is definite, permanent, a specific value it holds. That is the main difference between a discrete random variable and continuous random variable. Now, see, in discrete random variable, the number of events are finite because limited number of events will be there. So for them, definitely they will take some specific value. That's why the probability will be a definite value, specific value. Whereas in continuous random variable, since its value lies in an interval, that's why its value goes in particular range. It takes some constant graph. So that's why it comes under continuous random variable. So while discussing some very interesting problems, sums on discrete and continuous random variable, we first of all we have to keep it one point mainly, that is discrete random variable always takes a specific value, a numerical value, whereas in continuous random variable it takes the value in some range, in a particular range. That is the main difference between discrete random variable and continuous random variable. See, in discrete and continuous random variables, if we see the main difference, a discrete variable is a variable whose value is obtained by counting, by oral counting. We can find its value. It is possible for discrete random variable. Whereas while we are doing in continuous variable, it is a variable whose value is obtained by measuring. That is the main difference between counting and measuring. The value which is obtained by counting is a discrete random variable. The value which is obtained by measuring is known as continuous random variable. So there are two types of random variables, discrete and continuous. So random variables that can assume only a countable number of values are called discrete. Random variables that can take on any of the countless number of values in an interval are called continuous. That is the main difference between discrete random variable and continuous random variable. Now, under discrete random variable, what can we see as examples? Number of students present, countable. Number of red marbles in a jar, it is evident, clear, countable. Number of heads when flipping 3 coins, limited. Next, students' grade level out of some 100 or out of 50 or out of 20, it is limited. So like that only its grade will be determined there. So it comes under limited case. So all these are examples, suitable examples for discrete random variable. Now what can we see examples for continuous random variable? Height of students in a class, weight of students in that class, time it takes to get to school, distance traveled between classes. All these, why here continuity is there? Here height of students means some student may have 155 centimeters, other student may have 158 centimeter, some tall student may have 161 centimeter, some shorter may have 152 centimeter. So it is going from some range 150 centimeters to 165 centimeters. So here that height, that parameter height lying between some interval, some class interval or whatever it may be, some range. Same like that weight also. Same class students, one may weigh 40 kg, one may weigh 45 kg, one may weigh 48 kg, one may weigh 50 kg. So it depends upon their body structure and flesh of the body, and like that it goes from 40 kg to 50 kg. It maintains some range, some interval. That is what continuous. So the height of the students, weight of the students, time it takes to get to school. Some persons may go for 9 o'clock, some students may go for 9:30, some Jilla Pasad school students may go for 10 o'clock, university students may go for 10 o'clock, engineering college students may go for 9 o'clock. So it depends upon some interval or range. That's why it is best example for continuous variable. Like that, distance traveled between classes. So it may be some 10 meters away, some 15 meters away, some 20 meters away. So it also comes under some continuous range. So all these are very suitable examples for continuous variables. Now let us see, a random variable is a variable whose value is a numerical outcome of a random phenomenon. Earlier we have discussed. A random variable is denoted with a capital letter, like that, some x, like that. So the probability distribution of a random variable x tells what the possible values of x are and how probabilities are assigned to those values. This is very, very important. A random variable can be discrete or continuous, but how can we judge? By two main properties, countable or uncountable. If it is countable, this comes under discrete. If it is uncountable, comes under continuous. So a discrete random variable x has a countable number of possible values. Like that, continuous random variable, it has unlimited values. Its value comes under a range or interval. Now let us see carefully this table. Suppose some persons are there. So we are depicting some histogram for this data. Here x is taking the values from 2 to 12, and their corresponding probabilities are given here. P of 2 is equal to 1 by 36, P of 3 is equal to 2 by 36, P of 4 is equal to 3 by 36, and so on. P of 12 is equal to 1 by 36. Here, this graph shows the probability distribution of a discrete random variable. Now, we are going to construct a probability histogram for this. So for that, here x represents the sum. Suppose we are taking like this. Same sum we are taking like this. Here x represent the sum of two dice. Then the probability distribution of x is as follows. So there is no choice for two dice to become sum 1. That's why 1 is not there. Because the minimum number is 1. If first dice shows 1, second die shows 1, then 1 plus 1, 2. So the least sum is 2. That's why it is started from 2. And the maximum number, here 6, here 6. 6 plus 6, 12. That's why this range goes from 2 to 12. Now, this table depicts that the probability to come the sum 2 on 2 dice is P of 2. It is given as 1 by 36. So, here the probability to get the total sum 12 is 1 by 36. So, like that this table is given here. Here the probability distribution of x is depicted here like this. On x-axis we are taking outcome. It is from 2 to 12. On y-axis we are taking probability from 0 to 0.20. So by depicting the outcome on x-axis and probability on y-axis, we are getting histogram like this for the given data. At the outcome for 7, the maximum probability is more than 0.15. It is nearly 0.16 from this histogram. So, a continuous random variable x takes all values in a given interval of numbers. Like that, the probability distribution of a continuous random variable is shown by a density curve. Here, like that, this density curve, from this density curve, we can analyze the probability for a given different random variables. One more thing, the probability that x is between an interval of numbers is the area under the density curve between the interval endpoints. Like that, the probability that a continuous random variable x is exactly equal to a number is 0. So, like that, we can discuss their probabilities. Now, let us see some more examples of discrete random variables. See the number of cars sold by a car dealer in 1 month. Like that, the number of students who were protesting the tuition increase last semester, the number of applicants who have applied for a vacant position at a company. Like that, the number of typographical errors in a rough draft of a book. For each of these, if the variable is x, then x is equal to 0, 1, 2, 3, etc. Note that x can become very large. So in statistics, when we are talking about the random variable itself, we write the variable in uppercase, and when we are talking about the values of the random variable, we write the variable in lowercase. So let us see some more examples of continuous random variables. The length of time it takes a truck driver to go from New York City to Miami. Like that, the depth of drilling to find oil. The weight of a truck in a truck weighing station. The amount of water in a 12-ounce bottle. For each of these, if the variable is x, then x is greater than 0 and less than some maximum value possible. But it can take on any value within this range. So, let us see some interesting problems on discrete and continuous random variables. See first one. Find the range for each of the following random variables. What they are asking for first one? I toss a coin 100 times. Let x be the number of heads I observe. Second one, I toss a coin until the first heads appears. Let y be the total number of coin tosses. Like that, third one is given. The random variable t is defined as the time in hours from now until the next earthquake occurs in a certain city. Here, 3 tasks are given. Now, let us find the range for each task. Here, the random variable x can take any integer from 0. Here, see, head to tail, 2 chances are there. That's why they are taking 0, 0 to 100. So, like that, they are counting. Then the numbers, the range may become 0 to 100. So the range for head is 0 to 100. The range of tail is also 0 to 100. So the random variable y can take any positive integer. Then range of y is equal to set 1, 2, 3, etc. So it is nothing but natural number set. N is equal to set 1, 2, 3. So the random variable t can in theory get any non-negative real number. So range of t, this is the answer for third question. Range of t is equal to closed interval 0 to open interval infinity. So it is from closed 0 to open infinite. Now let us see one more one. Classify each random variable as either discrete or continuous. By seeing that, we have to judge, we have to tell whether it comes under discrete or continuous. Here, the number of arrivals at an emergency room between midnight and 6 a.m. What does it mean? It comes as a discrete because it is countable. Next, the weight of a box of cereal labeled 18 ounces. It comes under range. That's why it is continuous random variable. The duration of the next outgoing telephone call from a business office, clearly it is continuous. D. The number of kernels of popcorn in a 1 pound container, we can count. So it comes under discrete. Next, the number of applicants for a job, we can count. So it comes under discrete. Now let us see some more examples. Let us classify them. The number of boys in a randomly selected 3-child family, we are counting 3. So evidently it comes under discrete. Question B. The temperature of a cup of coffee served at a restaurant. No, you cannot count. Continuous. C. The number of no-shows for every 100 reservations made with a commercial airline. 100 we are only telling. Countable. Discrete. Fourth one. The number of vehicles owned by a randomly selected household. Discrete. We are countable. Fifth one. The average amount spent on electricity each July by a randomly selected household in a certain state. Uncountable. So it comes under continuous. Now let us classify these things either discrete or continuous. The time between customers entering a checkout lane at a retail store, is it countable or uncountable? 0, 1, 2, 0, 1, 2, like that. We can count them. So the time between customers entering a checkout lane at a retail store, so it is countable. And discrete. The weight of refuse on a truck arriving at a landfill, see, it comes under interval AB. The number of passengers, third one, the number of passengers in a passenger vehicle on a highway at rush hour, it comes under interval AB, some closure, open interval A comma B. Next, the number of clerical errors on a medical chart, we can count because it comes under discrete. The number of accident-free days in 1 month at a factory, some maybe 2, 3 like that countable, so it comes under discrete. So probability distributions for discrete random variables. So these are associated to each possible value x of a discrete random variable x is the probability p of x that x will take the value x in one trial of the experiment. So the probability distribution of a discrete random variable x is a list of each possible value of x together with the probability that x takes that value in one trial of the experiment. For that, let us see one example. Each probability p of x must be between 0. So 0 less than or equal to p of x less than or equal to 1. That is where we know 0 less than or equal to probability of any event is less than or equal to 1. This is the main probability condition. The sum of all probabilities means sigma p of x is equal to 1. Sum of all probabilities is 1. So now let us see. A fair coin is tossed twice. It is tossed 2 times. Let x be the number of heads that are observed. Now let us construct the probability distribution of x. And one more question is also asked here. Find the probability that at least one head is observed. Here 2 cases are there. The fair coin is that fair coin is tossed twice, 2 times. So how many chances will be there? There will be exactly 4 chances will be there. Head, 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 tail, tail, head, tail, tail. So the possible values that x can take are 0, 1, and see, is a head or tail. Only 2 values, two possible values are there. 2 events will be there. So the possible values that x can take are 0, 1, 2. Why? If nothing is there, it comes under 0. If one head, number of heads we count. If one head is there, we assign 1. If both are 2 heads are there, we assign 2. Like that, we give the numbering. Each of these numbers corresponds to an event in the sample space. S is equal to, here, what is the sample space? Head, 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 tail, tail, head, tail, tail. This is a sample space. Now, what we are picking out, find the probability that at least one head is observed. So, at least one head is observed means both 2 heads also can be there. But minimum 1 head should be there. So here sample space S is equal to head head, head tail, tail head, tail tail is similar to head head, comma head head of equally likely outcomes for this experiment. So here x is equal to 0 to we are giving x is equal to 0 for tail tail, and we are giving x is equal to 1 for ht comma th, and we are giving x is equal to 2 for h comma h. So the probability of each of these events, hence of the corresponding value of x, can be found by counting to give these values. This can be graphically depicted like this by this histogram. For no tails, 0. For one head, one tail, one tail, one head, middle one. If both are heads, second one. Like that, we are assigning histograms for this one. Now let us see the mean and standard deviation of a discrete random variable. The mean, also called the expected value, we know mean is known as expected value of a discrete random variable is nothing but it is average. The mean of a random variable may be interpreted as the average of the values assumed by the random variable in repeated trials of experiment. Now let us see this table. Experiment number x, possible values of x. Let us take the topic. Roll 2 fair dice. 2 fair dice we are rolling. Then what will happen? Let us take one task. Sum of the number of dots on the top faces. That is the parameter we are taking. Then their sum may become 2, 3, 4, etc. It goes up to 12. 6 plus 6. Maximum. 6 plus 6, 12. So, for this parameter, sum of the number of dots on the top faces goes from 2 to 12 for 2 fair days. Like that, take one more experiment. Flip a fair coin repeatedly. Here, what is the task we are taking? Number of tosses until the coin lands heads. Then the trials will go from 1, 2, 3, 4, etc. Let us take one more experiment. Let us do. Measure the voltage at an electrical outlet. Then voltage measured is our parameter. Then that voltage may be lies between 118 volts less than or equal to x less than or equal to 122. So it is lying under some interval. Let us take one more experiment. Operate a light bulb until it burns out. That is the experiment. So for that, time until the bulb burns out, let us calculate. So it lies between 0 and infinity. 0 less than or equal to x less than infinity. Like that, we can categorize. As a part of recapitulation, what we are going to do is discrete random variable and continuous random variable. They are the key structures of probability and distribution. This entire probability and distribution is discussed about depending upon the nature of these discrete and random variables. Discrete random variable always takes a fixed value, a definite value. It has a finite value, fixed value. Whereas a continuous random variable, it lies always in some range and an interval. So the best examples for discrete random variables, what we are finding when we are flipping a coin, coming heads or tails, all these things we can take. And the best examples for continuous random variable, we can take the heights of students of a class, weights of students of a class, like that we can take. We should have the proper idea about this discrete random variable and continuous random variable. Discrete random variable is always meant for countable things. So number of events are finite. For the continuous random variable, the things or events are infinite. That's why its values lies between some particular interval or range. That is the main difference between these two important random variables. Thank you. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.